It was past midnight when Hans Bethe knocked on my door at Los Alamos, and I could tell immediately from the particular way he knocked, 3 slow, deliberate taps, the way a man knocks when he has been thinking too hard and needs someone to think with him, that something unusual was eating at him. Hans didn't make social calls at midnight. Hans didn't make social calls at all, really. He was the kind of physicist who saved his words the way a miser saves pennies, spending them only when absolutely necessary, which meant that when he spent them, they were worth something. I opened the door in my undershirt. I had been working on something else entirely, a calculation about neutron cross-sections that had been giving me fits for 3 days, and my desk looked like a ticker-tape parade had passed through it. Hans looked at the mess, looked at me, and said nothing about either. He stepped inside, sat down in the only chair not covered in paper, folded his hands across his enormous chest, and said, "Richard, I want you to think about something that will probably seem foolish to you." Now that got my attention. Hans Bethe, calling his own idea foolish, was like the Rocky Mountains calling themselves a slight elevation. This man had calculated the energy production of stars. He had figured out that the sun burned through nuclear fusion cycles before most people had even accepted that the nucleus had cycles worth talking about. When Hans Bethe said something might be foolish, you sat down, you cleared your best thinking space, and you listened with everything you had. I pushed some papers onto the floor and sat on the edge of my desk. "Tell me," I said. He was quiet for a moment, in the particular Hans Bethe way of being quiet, which wasn't awkward or hesitant, but felt more like the pause before a very precise instrument gives you its final reading. Then he said, "I have been thinking about how something very large could disappear. I want to be honest with you about what I felt in that moment because it matters to the story. My first instinct, and I am not proud of this, but it's the truth, was a little flicker of amusement. We were in the middle of the most consequential weapons project in human history, surrounded by problems that had immediate, terrible, practical weight, and the great Hans Bethe wanted to talk about disappearing. But I had learned by then, and I was still learning it more every day, that the instinct to dismiss a question as impractical was almost always the instinct of a smaller mind trying to protect itself from the discomfort of genuine uncertainty. So I killed the amusement before it reached my face, and I said, "Tell me how." What followed was one of the strangest conversations of my life, and I have had some genuinely strange ones. Hans had been thinking, this was characteristic of him, these long private ruminations that he never mentioned until they were fully formed, about the cosmological work that Einstein had done decades earlier, specifically about the cosmological constant, that term Einstein had inserted into his field equations and later called his greatest blunder. The idea, roughly, was that empty space itself might have a kind of intrinsic energy, a pressure that pushed outward against gravity, that could in principle make the universe neither expand nor contract, but simply hold still. Einstein had eventually abandoned the idea because it seemed to require fine-tuning that felt artificial, like putting your thumb on the scale of the universe. But Hans had been turning the mathematics of it around in his mind like a stone in a polisher, and he had noticed something that bothered him. The equations didn't just allow for a static universe. They allowed for something stranger, regions of space where the energy density of the vacuum itself varied, where empty space had more or less of this intrinsic energy than the space next door. And in those regions, light would not travel the way we expected. If you're enjoying this story so far, I hope you'll consider subscribing. There are dozens more conversations like this one waiting for you, each one a window into how physics actually gets made. I remember the specific physical sensation of understanding starting to build in me, which for me has always felt like a kind of pressure behind the eyes and a simultaneous loosening in the shoulders, as if 2 opposing muscles have been fighting and one of them suddenly lets go. I leaned forward. "You're saying the refractive index of space itself could change," I said. Hans nodded slowly. In that way that meant yes, and also there is more. And the more is the part that is keeping me up past midnight. Here is the physics, because the physics is the story. In ordinary optics, when light moves from one medium to another, from air into glass, say, or from water into air, it bends. It bends because it slows down, and when a wave slows down at an angle, the geometry of the wave forces it to change direction. This is refraction, and it is beautiful, and it is everywhere. Now, what Hans was describing was a situation where the vacuum of space itself had an effective refractive index that could vary from point to point depending on the local energy density of the vacuum state. In such a region, light would bend, not because of gravity, not because of any mass, but because of the energy of nothing. The implications of this started arriving in my mind the way a mathematical series converges, each term adding something significant. If you could engineer a region of space with a particular vacuum energy profile, you could in principle bend light around an object, not just bend it slightly the way gravity bends starlight near the sun, but bend it completely around so that an observer on the other side would see straight through the space where your object was sitting, would see the background stars perfectly, would have no optical indication whatsoever that anything was there. I stood up. I actually stood up, which I rarely do when I'm thinking, because thinking for me is usually a sitting still activity. I walked to the window and looked out at the New Mexico desert, which was doing its usual middle-of-the-night thing of being vast and dark and slightly threatening, and I said, "Hans, that's a cloaking device." The word sounded ridiculous the moment I said it. We were physicists. We did not say cloaking device, but Hans, to his enormous credit, did not flinch. He said very quietly, "Yes, I think that is precisely what it is." What happened next in the conversation is where it gets complicated and where it changed me in ways I am still, decades later, working out the full implications of, because Hans then said something I was not expecting. He said, "I am not the first person to notice this. And the reason I'm telling you at midnight rather than at the seminar table is that I am not entirely sure we should be telling anyone at all." I turned from the window. "Why not?" Hans looked at his hands for a moment. When he looked up, there was something in his expression I had never seen there before. Not exactly fear, but something in the family of fear, a first cousin of it. He said, "Because if the mathematics works, then it also works in the other direction. And I have been asking myself, Richard, whether the silence of the sky might be an answer to a question we haven't quite learned to ask yet." That sentence hit me like a physical thing. I stood there in my undershirt in my messy room at Los Alamos, surrounded by the debris of my own calculations about weapons that could destroy cities, and Hans Bethe, the man who had figured out how stars burned, was suggesting to me that the emptiness of the observable universe might not be emptiness at all. It might be full of things that had learned or been built to look like nothing. Let me explain why this was not a crazy thing for a serious physicist to say, even in 1944, even in the middle of a weapons project, even at midnight. The universe was already by that point understood to be incomprehensibly old and incomprehensibly large. The calculations that established the age of stars and the distances of galaxies had already been done. Anyone who sat with those numbers long enough had to eventually confront the sheer improbability of our being the first or the only technological civilization in something that had been running for billions of years across billions of galaxies. Enrico Fermi, who was working in the same project in a building half a mile away, would pose this as a formal question in a few years' time, at a lunch table in a moment that became famous. But Hans was there first, in my room, in the dark, and he was posing it not as a lunch table speculation but as a physics problem. If a sufficiently advanced civilization understood the vacuum energy structure of space-time, Hans was saying, they would not merely be able to hide an object, they would be able to hide themselves. They could engineer their local space-time environment to be electromagnetically transparent from the outside, to absorb and re-emit radiation in patterns that looked exactly like unoccupied space. They would be invisible not through any technology we would recognize as a technology, but through the fundamental structure of what empty space actually is. If this kind of deep dive into the physics you never got in school is what you've been looking for, subscribe, because we're just getting started. And the next conversation goes somewhere even stranger. I asked Hans how you would even detect such a thing. He said very carefully that you probably wouldn't, not directly, but there would be gravitational signatures, a region of apparently empty space that bent light slightly more than its apparent mass should warrant. That contributed to the rotation curves of galaxies in ways that didn't quite add up, that seemed to account for more of the total energy budget of the universe than visible matter and radiation could explain. You would look at the universe, Hans said, and you would find that the numbers didn't balance. You would find that the majority of the energy in the universe seemed to be in a form you couldn't see, couldn't detect with any instrument, couldn't interact with in any ordinary way, but whose gravitational effects you could not ignore. I remember a very specific cold feeling, distinct from the New Mexico night. Not fear, exactly. More like the feeling of a door opening onto a space you hadn't known was there, and not being entirely sure whether you wanted to walk through it. The reason that conversation changed me, and it did change me in ways that took years to fully surface, was not just the scientific content, as extraordinary as that content was. It was the lesson Hans was teaching me about the relationship between absence and evidence. I had been trained, we had all been trained, to think that the absence of a signal was evidence of absence. No radio emissions from that direction, nothing there, no visible structures, nothing there, no spacecraft showing up in our orbit, nobody coming. This was the default assumption of science, and it was a reasonable assumption, and it had served us well for the specific problem of figuring out how atoms and nuclei and stars worked. But Hans was showing me, through this strange midnight physics exercise, that the assumption broke down catastrophically the moment you allowed for the possibility that the hidden thing had specifically engineered itself to satisfy the absence condition. A civilization that understood dark energy, that understood the vacuum energy of space as a manipulable medium rather than a fixed background, could construct its own absence. It could build the evidence of its own non-existence. The silence of the sky wasn't necessarily an empty sky. It might be a very deliberate sky. We talked until almost 4 a.m. At some point, Hans produced, from a pocket that seemed too small for it, a flask of something that turned out to be extremely good brandy, which I have always suspected he carried around specifically for conversations that warranted it. We worked through the mathematics together, which is something I have always loved doing with Hans because his mind moved in a fundamentally different way from mine, slower and more massively, like a great river rather than the quick stream of my own thinking, and together we covered ground that neither of us would have reached alone. What we found working through it was that the math was consistent. There was nothing in the known physics of 1944 that prevented it. The cosmological constant, the vacuum energy, the variation of space-time geometry on scales both large and small, all of it assembled into a picture that was, if not proven, at least entirely unbroken by the things we knew. A sufficiently advanced civilization, with sufficiently deep understanding of the vacuum structure of space-time, could make itself gravitationally present but electromagnetically absent. It could contribute to the universe's energy budget in ways that would eventually be attributed to some mysterious, apparently uniform, apparently structureless dark energy, and the structures within that dark energy would be entirely invisible to anyone who hadn't specifically designed their instruments to look for the gravitational signatures of deliberate geometric order within what appeared to be a featureless field. Hans left as the sky was starting to lighten, that particular pre-dawn gray that makes the desert look like it's been sketched in pencil. At the door he turned and said, with that characteristic Hans Bethe precision, "I am not saying they are there, Richard. I am saying that if they were there, we would not know. Those are different statements, but physicists have historically confused them, and I think we should try not to. I have tried not to for the rest of my career. That's the honest answer to what this conversation gave me. Not a new research direction, though it eventually fed into my thinking about quantum electrodynamics and the vacuum energy of fields in ways that were subtle and real. Not a settled belief about extraterrestrial intelligence, because Hans's point was precisely that the question couldn't be settled by direct evidence. What it gave me was a permanent, deep suspicion of confident claims about what isn't there. Whenever someone tells me with great certainty that something doesn't exist because we haven't found it yet, I hear Hans's voice at 4 a.m. saying, "That is a different statement, and I think we should try not to confuse them." The cosmological measurements that would confirm the reality of dark energy, the actual discovery that the universe's expansion was accelerating, driven by something in the vacuum that accounted for roughly 68% of all the energy in existence, invisible to every instrument except through its gravitational consequences, came long after Hans and I were young men in the New Mexico desert. When those results came in, I thought of that conversation immediately. I thought of Hans's careful, precise voice and his good brandy and the way he had knocked on my door, 3 slow, deliberate taps, because he needed someone to think with him about how something very large could disappear. The sky is not silent because it is empty. That is what Hans taught me. The sky might be silent for reasons that require much more imagination than emptiness. And the physics that would allow for that silence, the manipulation of vacuum energy, the engineering of spacetime's electromagnetic transparency, the construction of a gravitational signature indistinguishable from a uniform field, is not magic, not science fiction, not the territory of people who have given up on rigor. It is a straightforward, if technically extraordinary, consequence of the equations we already have. And the fact that we have named it dark energy, this unknown something that makes up most of the universe, that we cannot see or touch or measure directly, that we know only by its effects on everything around it, should give us pause. Not because we should leap to conclusions, but because the history of physics has a long tradition of discovering that the thing we called emptiness was always, all along, secretly full. Subscribe if you want to keep thinking about the secrets hiding in plain sight. There are more stories like this one, from the rooms and desktops and midnight conversations where physics actually happened. Hans knocked 3 times. That's the detail I keep coming back to. 3 slow, deliberate taps. The knock of a man who knows that what he's carrying is heavy and is hoping you're awake enough to help him carry it. I am glad I was.